In this video, we'll be going over the recursive approach of dungeon game. So the demons have captured the princess and imprisoned her in the bottom right corner of a dungeon. The dungeon consists of m times n rooms laid on a 2D grid. Our knight was initially positioned in the top left room and must fight his way through the dungeon to rescue the princess. So basically traversing from the top left room to the bottom right corner of the bottom right room. The knight has an initial health point represented by a positive number. If at any point his health drops below 0, he dies immediately. So his HP should only be positive to stay alive. Some of the rooms are guarded by demons represented by negative numbers. This means he's losing health the moment he walks in the room. So the knight loses health upon entering these rooms. Other rooms are either empty, represented with 0, or contains a magic orb that increases the knight's health, represented by positive integer, which basically the magic orbs increases the HP of the knight. To reach the princess as quickly as possible, the knight decides to move only rightward or downward at each step. Return to the knight's minimal initial health so that he can rescue the princess, which means the minimum health at the initial top left corner. So note that any room can contain threats or power-ups. Even the first room the knight enters in the bottom right room where the princess is imprisoned. So in our first example, we're given this grid, and then the knight starts at here, and then the princess over here. So the initial HP the knight should have is 7 in order to save the princess. So let's go over the thought process. So the knight will initially start at cell 00. Then for each of the cell RC, we have two choices. We can either move rightward or downward. We will pick the choice that will give us the minimum amount of health. Now, what's the base case? So after the knight, for example, after the knight saves the princess over here, what if the knight continued to move rightward or downward? What's the HP of the knight? Since we want the knight to stay alive, the minimal HP the knight should have after saving the princess should be equal to 1. So for example, if there's a cell here, or there's a cell down here, if the knight continues to move forward, the knight should have an HP of 1 at this cell and also at this cell. If we have an m times n grid, if the knight step into the cell located at m at n minus 1, which means the cell over here at the bottom here, the knight's HP or health should be equal to 1. Also, if the knight step into the cell located at m minus 1 at n, which is a cell here to the right here, the knight's health should also be equal to 1. Now let's go over the pseudocode. So we're going to implement the recursive approach. So what parameters do we need? We first need the row, the current row, and cell or column, the current column, C, the current column, and also the input dungeon, the input matrix. Now what's the base case? If RC is equal to m and n minus 1, or n minus 1 and n, we can return 1. The minimum HP we need for the knight to stay alive after saving the princess is going to be 1. Now if RC is out of bound, or any other cell that's currently out of the grid, we want to return integer.max value, which basically just an error say the knight should not walk into the cell. Then each of the recursive call. We're going to recursively find the minimal health h1 of moving rightward, because we're only allowed to move rightward and downward, so it's just c plus 1. Moving rightward is just moving the column to the next column to the right. So recursively find the minimal health h2 of moving downward. Now moving downward is just increasing the row by 1. Now find the health at the current cell, the minimum health at the current cell. it will be equal to, we want to take the minimum value between the two choices and then minus dungeon RC. Why do we need a minus dungeon RC? For example, after we save the princess, and then we have HP of 1, and then we step back into this cell again. In order for the knight to be alive at this cell, we need to, after the knight leaves the cell, we're going to have an HP of 1. But then what's the HP of the knight coming into the cell? When the knight comes into the cell, the HP must be equal to 6, because 6 minus 5 is equal to 1. So we take the minimum value and then we minus. So 1 minus -5, we get 6. Now, if health is less than 0, this means the minimum health of staying alive at this cell can be any positive value, since we want the minimum health we need, so we can just return 1, else we can just return the health. Now let's go over the time and space complexity. The time complexity is O to the 2 to the n plus n, where mn are the numbers of rows and columns. Is because each recursive call has up to 2 choices and a depth of n plus n. Our space complexity is O of n plus n. This is our recursive call stack memory. Now let's go over the code. So we're going to create a helper recursive method. Our initial cell is 0, 0, which is the top right corner. So the current row, the current column, and the input dungeon. We also pass in 2 more variables to make it easier for us. So basically dungeon.length and dungeon0.length, which basically indicating the numbers of rows and columns. This is just for easier calculation. We can write it down here too. 1, 2. The number of rows and the number of columns. Now our base case, if R is equal to M and C is equal to M minus 1, or R is equal to M minus 1 and C is equal to N. This is the base case that we talk about after we finish saving the princess. What's the HP that the knight should have to stay alive? So it's going to be return 1, it's going to be 1 HP to stay alive. And then if R is greater equal to M, or C is greater equal to N, this means the cell is out of bound. This means the knight is currently in an invalid position. So I want to return integer.max value, which basically it's just an error code to prevent the knight from stepping to this cell. Now we want to find the HP of moving the knight rightward. C+1 dungeon and mn, and the HP of moving the knight downward. Then we want to find the current health, which is the minimum value between the 2 choices, and then also accounting for the current cell, which is minus dungeon RC. Then we can return health. If health is greater than 0, we can just return health. Else, if it's a negative value or 0 below, this means the knight can't have any amount of HP of staying alive in this cell. So we want, of course, we do not want a 0 below HP for the knight. So the minimum HP we can have is going to be 1. Okay, we're getting a TOE error. So let's write this down. So this approach is not efficient enough and will result in TOE error. in our second video, where we are going to go over the memorization approach of dungeon game. Let me know if any questions in the comment section below.